Collision Theory by Haley and Christine.
Here is some information that we need to know before learning about collision theory. We need to know about the kinetic molecular theory. There are 3 important points when it comes to the kinetic molecular theory. The first point is that particles move faster at higher temperatures.
The second main point of kinetic molecular theory is that particles collide elastically, which means that they travel in straight lines and bounce off of each other and the walls of the container.
The third point is that particles don't experience intermolecular forces because they are very far apart from each other.
Also recall that at one temperature, not all particles are moving at the same speed. Also, the distribution of all speeds of each particle is that of a normal distribution.
Now we can take a look at collision theory. What is collision theory? Collisions occur when 2 molecules collide or one molecule collides with the walls of a container. This has the potential to result in a chemical reaction.
There are 2 types of collisions, effective and ineffective collisions. Only effective collisions can cause a chemical reaction. However, 3 conditions must be met in order for this to happen.
The first condition is that molecules needed for the reaction must be present.
The second condition is that all molecules must have a minimum energy, or speed, at the collision as indicated by the previously determined activation energy.
The third condition is that all molecules must collide at the appropriate location at the same time, or in other words, have proper orientation.
If even one of the above conditions fails, it results in an ineffective collision where no chemical reaction occurs. The molecules simply bounce off of each other elastically.
Now let's take a look at condition number 1, presence. In order for a chemical reaction to occur, the correct molecules must be there. Imagine a chemical reaction without the molecules being there. If a molecule is missing, ineffective collision will occur.
Here's an analogy to help you picture it. Say a breeder wants to make a golden doodle. They must have the right types of dogs present in order to make this breed. Both a golden retriever and a poodle must be the molecules in the collision in order for the golden doodle puppies to be made. If one of the breeds are missing, this will result in an ineffective collision and no puppies will be there.
Consider this other analogy. If you want to bake a cake, you have to have all the ingredients. Let's say you're missing sugar. Then the cake can't be made and ineffective collision occurs.
Now let's look at condition 2, speed. Some molecules move at a slower speed than others. If their speed is lower than the activation energy, which is represented by the red vertical line, then ineffective collision occurs. Remember that activation energy is the minimum amount of energy needed for effective collision to occur.
Let's take a look at an analogy. Think of 2 people. One person is stationary and another is walking at a slow pace. Say the person walking bumps into the stationary person. Both people will barely feel the bump and probably just continue on with their day. Now think of 2 people running in opposite directions and colliding. Most likely, a lot of damage will be done. The same concept applies for particles colliding. The more speed, the more damage, and thus effective collision.
Consider this other analogy. iPhones are very delicate. Dropping them lightly can possibly result in a scratch or 2. However, smashing it on the ground with a very high speed can seriously damage your phone beyond repair. This proves that higher speeds results in effective collision. When the activation energy requirement is met, along with the other 2 conditions, this doesn't necessarily mean that a chemical reaction is 100% guaranteed. This only leads us to our next step, the activated complex. This occurs at the moment of collision and represents the maximum potential energy point in the reaction.
An activated complex is an unstable chemical structure that doesn't really exist. Let's take a look at this example. We can see that bromomethane and chlorine react to give us chloromethane and bromine. The structure in the middle is the activated complex.
The chlorine and the bromine attached to the carbon are both half bonds. The chlorine to carbon is a partial forming bond, and the bromine to carbon is a partial breaking bond. At this state, there are 2 options. Chlorine can solidify and bromine breaks off, or chlorine dissolves and bromine remains. This is based on the activation energy.
Remember that chlorine should hit carbon with the proper orientation. Also, in order to have a better chance of a new product being formed, Chlorine should have the minimum amount of activation energy plus a bit more.
Now let's look at condition 3, orientation. Effective collision relies on a very specific orientation of the molecules present in the collision. They must collide in a certain location at the same time, with the other conditions also met.
Let's take a look at this analogy. Think of the human body. Some parts are more fragile than others. Say you hit your foot. This results in a bruise or two. But if you hit your head, injuries can be very severe. This is the same for molecules. When a molecule collides and the delicate location is hit, this results in effective collision because more damage will be done.
Another analogy is when playing tennis, the goal is to put spin on the ball by hitting the ball to the racket at a certain orientation. This creates a trick spin, which should also be thought of as effective collision.